Alright, so today we're going to do a review of right triangle trig, which you should have already learned, but just in case, we're going to go over it again. So, a ratio of the lengths of sides of a right triangle is called a trigonometric ratio. I'm just going to abbreviate it as a trig ratio. So the three most common trig ratios are sine, cosine, and tangent. Alright. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so how can you remember this? So there is a saying, and it goes, some old horse came a hopping, through our alley. Some old horse came a hopping through our alley. So this S stands for sine. This is opposite. This is hypotenuse. So sine is opposite over hypotenuse. This C is for cosine. A is for adjacent. This H is for hypotenuse. So cosine is adjacent over hypotenuse. This T is for tangent. O is for opposite. A is for adjacent. So tangent is opposite over adjacent. So there's a lot of different sayings out there for remembering these. This is the one I use. If you already have one that you've used, I know some people use SOHCAHTOA. That's perfectly fine. Whichever one you use to memorize it, whichever one sticks in your head. So hypotenuse is the longest side of the triangle, and it's actually the only one that can't move. Okay, and it's actually located directly across from the right angle. This should not be triangle, this should be angle here. Alright, so let's see how the opposite and adjacent sides can move. So it depends on the location of the angle. So here, X is our angle. We can go ahead and label our hypotenuse as always the one directly across from the right angle. This one never changes. So on this triangle, it's directly across from the right angle. And you can see it's the longest side. But if you can't tell which side's the longest, you can always look. It's going to be directly across from that right angle. Now, this angle, which side is going to be opposite that angle? Is it going to be this one? Or is it going to be this one? The opposite side is going to be over here. It's directly across from it. Directly across. Now the adjacent is going to be the one that touches the angle, but it's not the hypotenuse. So it's touching our angle here, but it's not the hypotenuse. Okay, let's move on to the next one. So in this triangle, our angle's up here. which side is directly across from that angle, opposite that angle? Is it this side or is it this side? It's going to be this side. This is the opposite. So that means this is going to be the adjacent, which makes sense. This side touches the angle and it's not the hypotenuse. So you can see how the opposite and the adjacent sides move. They're not always in the same location. The hypotenuse is, though. It's always directly across from that right angle. So using trig ratios, remember that they only work for right triangles. So if we have a triangle that's not right, we cannot use these ratios. So our first example, find sine A, cosine A, tangent A, sine B, cosine B, and tangent B. Express it as a ratio of express each ratio as a fraction and as a decimal. So let's work with angle A first. So that's going to be this angle here. So sine A is going to be opposite over hypotenuse. So sine A, we're using angle A, so 3 is opposite angle A, and 5 is our hypotenuse. So we're going to have 3 over 5, which is 0.6. So for angle A, this is our hypotenuse, 3 is our opposite, 4 is our adjacent. So cosine A. Cosine is adjacent over hypotenuse. Came A hopping. So adjacent is going to be 4. Our hypotenuse is 5. So we're going to have 4 over 5, which is about 0.8. And last one, tangent A, which is opposite over adjacent. So we're going to have opposite, which is 3, over adjacent, which is 4. It's going to give us 0.75. Alright, so let's erase. So now for angle B, B is going to be here, so these no longer apply. So for angle B, our opposite is going to be 4, our hypotenuse is still 5, our adjacent is 3. So sine B, which is opposite over hypotenuse, will be 4/5, which is 0.8. Cosine B, which is adjacent over hypotenuse, will be 3/5, which is 0.6. And tangent B, which is opposite over adjacent, will be 4/3, which is about 1.3. Okay, let's look at one more example. So we're finding the same thing, but this time we have a side that's missing. So we have two sides of a right triangle, one's missing. Do you remember how to find that missing side? So you need to recall the Pythagorean theorem. So a squared plus b squared equals c squared, where c is always our hypotenuse. So in this case, we're going to have 8 squared plus 15 squared equals c squared. 8 squared plus 15 squared is 289. Take the square root, so C is 17. Now we can find everything else. So sine of r, cosine of r, tangent of r. So let's look at r. So for r, our opposite side will be 15. Hypotenuse is always going to be 17. And 8 is our adjacent. So directly across from r is 15. Touching r is not the hypotenuse is 8. And then directly across from our right angle is 17. Alright, so sine is opposite over hypotenuse, so we're going to have 15 over 17, which is about 0.88. We're going to have cosine, which is adjacent over hypotenuse, so 8 over 17, which is approximately 0.47. And tangent, which is opposite over adjacent, so 15 over 8, which gives us 1.88. Okay, so now let's find sine of s, cosine of s, and tangent of s. So our adjacent and hypotenuse are going to change now because we're using this angle. So directly across from this angle is 8. So that's our new opposite. And then 15 will become our adjacent. So 8 is across from 15, our hypotenuse stays, and 15 is the side that touches our angle that's not the hypotenuse. So sine is opposite over hypotenuse, so we're going to have 8 over 17, which is 0.47. Cosine is adjacent over hypotenuse, which is 15 over 17, which is about 0.88. And tangent, which is 8 over 15, which is about 0.53.